A very good morning to all of you. I, Trupti Shripad Tagare, along with my co-authors Dr. Rajeshri Narendra and Dr. T.C. Manjunath, would like to present before you a part of my research work entitled Simulation of Routing Protocol Development using Relay-Based Cooperative Routing Concepts in WSNs. These are the contents of my presentation. Let's quickly move on to the introduction part. The wireless sensor networks are made up of large number of tiny sensor nodes. These nodes are often called as modes. They are displaced in inhospitable and inaccessible environments in order to find the physical parameters of the environment like pressure, humidity, temperature, vibrations, etc. Now these are the nodes that are being placed in that particular area which need to sense that physical parameter and further move the data towards the sink and then connect it remotely to the internet and have a controller in order to control these parameters. So this is the framework of a wireless sensor network. Now these nodes have a very limited source of battery and hence utilizing the energy present in these nodes efficiently is one of the basic requirements in a wireless sensor network. There are different types of nodes available. We can have them static or dynamic. When we are going to place them fixed, the location is fixed, then we call them as static. When the position or the location of these nodes is going to be random and mobile, then it is going to be called as dynamic nodes. So here in this research work, we are going to consider the nodes to be static. Different routing protocols were proposed by different researchers in order to have the energy efficiency of the network obtained. And these routing protocols are divided into different categories, namely the flat routing based protocols, hierarchical based protocols, and the location based protocols. Now let's come to the objective of this particular research work. Here we want to develop an energy efficient cooperative mechanism using a revised relay based cooperative routing protocol which has an abbreviation as RBCRP protocol. So here we are going to aim to increase the network lifetime, reduce the delay, that is end-to-end delay between the time taken by the data packets to be moved from the source to the sink and vice versa, and use of relay nodes for the data packets transfer, reduce the energy consumption and compare the results that we obtain from this proposed algorithm with the AODV protocol and see the results. So the previous works, huge lot of research is being carried out in this particular domain and several academicians have worked on this issue of energy efficiency and increasing the lifetime of the network. So a lot of research through the literature papers was done during this particular when this particular research work was carried out, and a quick evaluation of the work of several authors is offered in this paper along with their benefits and limitations. And we also checked with the diverse sources, analyzed the depth of how the protocols work and what were the consequences. These were all evaluated, and then in our research work we've concentrated on the relay based methods, and whatever were the flaws or shortcomings present in the previous works, they were studied, and a sincere effort is now being made in order to develop some high efficiency algorithms. So here the tools used in this research work is the network simulator tool NS2 2.35 version, and these are the remaining specs that we have used for the computer, the laptop that we have used in order to carry out this particular research work. Now coming to the energy model, the wireless sensor network that we considered as a graph of G, V of E, where V stands for the number of vertices and E for the edges, and then the edge E of ij of the graph is labeled, and here we considered the relay fading distribution to model the channels, and the decode and the forward approach was used in all the sensors, and the received packet is decoded, then it is re-encoded without verifying it before transmitting it. And the signals of the packet received by the destination and overheard by a relay can be expressed using the mathematical model equations that are being given here. So these were the things that we used in order to design the energy model. Now for next, now let's have a look at the NS2 simulation and the results. So NS2, that is the Network Simulator 2 tool 2.35 version, was used, and it's been presented here with the results. So here the main TCL script file would run from the command prompt window, the NAM window would appear, and then we would run the simulations and the results are being observed. The simulation parameters that were set for this particular work is we begin with the network with initially single node, and then we gradually increased it to 35 nodes, and this was distributed in a single side length of 200 meters, and we considered the relay fading with quasi-static fading for the fade in the channels, and here each packet fades randomly and independently. We also assume that the network's channels are entirely symmetric. Further, the node uses 17.4 milliamps for transmission, 19.7 milliamps of current for reception, and 103 milliamps in a static mode itself. That is, when all these nodes are going to be in their fixed locations. So these are the results that are being obtained from the work. Here, this first figure represents how the 35 nodes are being placed and how they are being randomly deployed. So this is the NAM window on which these are appearing. The next figure, which is for the RBCRP algorithm that we have proposed, we have seen that this orange path that is being observed, this is for the one that we have got for our proposed technique, which is the shortest path, and we've from the source to destination and vice versa. Further, the plot of network lifetime is also being done along with the number of exhausted nodes. So we can see that most of the nodes get exhausted in the path when it is the AOMDV or the AFDR protocol, and it was observed for the proposed technique the network lifetime was more, which is being depicted more decently here in the next slide here. So in figure 5 we can see the plot of the network lifetime. So this is the one which is in red, shows the proposed RBCRP technique, and it has been compared with the two other famous techniques of ad hoc multipath distance vector protocols and a variation in that. So it shows that for our proposed technique the network lifetime is much better compared to the other two. Also, the next plot shows the delay versus the number of nodes. So here, when we have seen that the number of nodes have been increased, the delay is going to be reduced actually. So this is what we get to know from our proposed technique, that our particular proposed technique works better when the number of nodes increase. Next, plot 7 shows the plot of a throughput with respect to time and comparison with the again AOMDV and AOFDVR techniques. So here the throughput is much better, it's high compared to the remaining two, and this is the plot of the packet delivery rate, that is the rate at which it's the verification of the fail rate as a function of time and in comparison with the AOMDV and the AOFDVR. So the fail rate is very low and hence the packet delivery rate is high. So it's going to be high in case of the proposed technique. So basically AODV protocol and the variations, that is AOMDV, AFDVR, they follow usually single path, and AOMDVR, it follows the multipath. So we have checked for all these techniques and proposed this RBCVR, which also works on multiple paths, so that we can increase the amount of data that we want to transmit towards the sync. And the proposed RBCR protocol, which was compared with the other AODV techniques, it showed that it showed better results when compared to the later two techniques, and it also minimized the delay. And with respect to the energy consumption, the proposed system is utilizing less energy, throughput is high than compared to the other two methods. Coming to the conclusion part, the routing protocol development for a cooperative wireless sensor network was proposed and presented in this paper, and it's an improvised version what we have developed right now, and we have compared the results with AOMDV and AOMD FTVR protocols. And from all that inferences that we have got from the simulations, it's seen that the number of data packets received by the sink grows, the electrical energy consumption decreases and results in a higher throughput for a proposed RBC-PRP technique. And finally, the routing algorithm computes a routing path which is based on the energy usage and the channel quality. Both these things are taken into consideration, which was accomplished in this section of the work that was carried out. And the simulation findings show the effectivity of the proposed methodology. So these are the references for my work. Thank you.